Calculate the distance from point S, which is 3, 7, negative 4, to the plane 6x, negative 3y plus z equals n. Okay, so I think there's a formula for this, but I am terrible with memorizing. Memory of a goldfish, and so I'm just going to kind of reason my way through this. Start by drawing a picture, pretty much the same thing you do for anything in life. We have some random point here, point S, and we want to find its distance to a plane right down here. Whoop, like so. And so the first thing we want to do is we want to find a normal to the plane. So I'm going to find a normal just right here, whoop, whoop, like so. So the nice thing is when we have the plane written in this form, A, B, and C, then a normal to the plane is going to be A, B, C. And normal just means a perpendicular. So we want a normal with a length of 1. That way it basically is just giving us direction without a magnitude. So to do this, I'm going to say that our normal vector is 6, negative 3, and 2. And to normalize it, to make it of magnitude 1, make a little hat on it like that. And for normal, little hat for magnitude 1. We're going to divide by the magnitude of this vector, which is going to be 6 squared plus 3 squared. Actually, it's negative 3 squared, but the negative is going to disappear, and then we square root it. Basically, just Pythagorean theorem. And so rewriting this once, at least once, we're going to have little vector symbols on the side. 36 plus 9 plus 4. 36 and 9 is 45. 45 plus 4 is 49. When their powers combine, we have 7. 49, square root of 49 is 7. So we have 6, negative 3, 2, kapow, kapow, divided by 7, which is convenient. All right, so now we have our normal here. Now, I'm going to basically take another vector, make another vector. I'm going to make a vector between here and there, where from point S to the plane, just any point on the plane. And that will give us a vector. So what I'm going to do then is I can choose any point on this plane to do this. And I'm just going to choose the easiest one possible. So I can put in any combination of x, y, and z I would like to find a point on the plane. So to do it easy, I'm just going to put in 0 for all of them. And I know that there is a point on the plane of 0, 0, 0. Because I put in 0 for x, 0 for y, 0 for z, I get 0. And so 0, 0, 0 is a possible solution to equal 0. So this is on the plane. Excellent. So now we have that established. We want to find a vector between S and the origin, 0, 0, 0. So to do that, we're going to subtract S from, so we'll subtract the x value for S from 0, x value for 7, 0, 4. You'll see. So I'm going to call this vector S. Just for convenience, this will be 3 minus 0, 7 minus 0, negative 4 minus 0. Little vector symbol, which is going to give us 3, 7, negative 4. So now we have two vectors, and the key idea here is the shortest distance from a point to the plane, which I assume this is asking for the shortest distance, is going to be perpendicular like this. And so what we can do then is we can find the dot product between S right here and the normal vector, and that will give us this distance right there. It'll give us the portion of the two vectors that is parallel, and if it's parallel to a normal to the vector, normal to the plane, then the S will also be this portion. I'll call this S parallel to the normal vector. That will actually be the shortest distance because that will also be parallel. All right, let's go with this. Focus, focus. So we do vector S, normal with a little hat showing that it's length 1, because that's important. Yep, and that's a dot product symbol. So to do the dot product, we'll do 3, 7, -4, dot our normal, which is 6, -3, 2, and I just took out the 7. There we go. And so this is going to give us 6 times 3, or 3 times 6, which is 18 minus 21. Yep. Minus 8 all over 7, because the dot product of two vectors gives you a scalar, so this is a scalar. Let's see, -8 and 18 is 10. 10 minus 21 is -11. -11 over 7, but they're asking for a distance, and so I'm going to assume that means absolute value, just like a, I'm going to say positive. You have positive distances. You can't have a negative distance really per se. You can have a negative displacement, but not distance. So I'm going to say that the distance is from this point to the plane, this here, S parallel, the part of this from point S to any point on the plane, the portion of that that is parallel to the normal vector is going to be 11/7. And this 11/7 right down here, that will be your answer. So that is how you find that is one way to reason through it. I think there's a formula, you can plug it in, several formulas, but if you just want to reason through it, this is how you would do it. Hope that helped. See you next time.